Hey guys, in this video I'm going to be talking about lesson 3 of module 12, which is all about organizing and analyzing your data. So this first page under lesson 3 was just a fun activity that we did together in class. So if you missed class and want to know how it went about, just find a friend and ask them about it, but I'm not going to add it to this video. What I do want to talk about is correlation and line of best fit. So we can take sets of data and describe their degree of correlation based on what the graph looks like. So if you look at each of these 6 options here, the top 2 are what are considered strong degrees of correlation. And the reason for that is because the dots are fairly close together and almost make a straight line. They don't quite do so, but they are relatively close, so they are called strong. Moderate, we don't talk about moderate too much, but it's somewhere between weak and strong. You can still tell what direction it's going in. They're not super duper close together, but also not fairly far apart either, like weak is. Again, weak, you can still vaguely tell which way the graph is going, but the dots are much farther apart in both of these types. Now, none just means you have no idea what's going on here. There is no way I can tell whether or not this graph is increasing, decreasing, strong or negative. The dots are just all over the place. So there is no correlation between whatever those 2 variables were in this graph. Now, I did mention positive versus negative, and I want you to think about that just like we thought about lines last semester. So as you go from left to right on the graph, are the dots going up or are they going down? So as I look for the positive ones, which would be these 2 here, as I go from left to right, the dots are increasing. They are going up. So those are positive. For each of these examples, though, as I go from left to right, the dots are going down. They are decreasing. Okay, so that's why these are negative. That's the main difference between those types of correlation. So if I'm looking at these three examples down here, our job is to decide what the degree of correlation is by stating if it's strong, weak, positive, negative, or none. So if I'm looking at this very first one here, it is pretty close to a straight line. So I could say that this one is strong. Another one that I would accept is moderate, because it is a little bit farther apart than these 2 examples up here at the top. However, I would take either strong or moderate for this one. However, no matter which one of those 2 you choose, the dots are going up as I go from left to right on the x-axis. So this one is definitely positive. So I'm looking for one of these 2 words and the word positive. Now, if you look at the graph in the middle, it's just kind of in a circle. There's no kind of pattern going on or direction when it comes to those dots. So this one I'm just going to call none. I don't think there's any sort of correlation whatsoever with this graph, so you just say none. The last one here, once again, is roughly linear. It's very close together. Again, I would take strong or moderate here, but I think this one is more strong, and it is definitely negative. As I go from left to right, that graph is decreasing. So that is a negative correlation. Okay? So if we flip the page over, we're going to talk about more of the same types of things, just in a different form. So example 3 says, the following graph depicts the relationship between the heights of trees and the amount of time they are watered per day. So if I'm looking at this graph here, it is increasing as I go from left to right. So I would say that this is positive. It's a positive correlation. I would say it's moderate. It's not super strong, but it's not very weak either. So I would say that it is moderate. So then what does that tell us about the connection between the 2 variables, watering time and height of a tree? Now, the one thing that I want to point out here, since these dots are not in a straight line, they are not what we call causation, where one thing directly causes the other. The only way that it can be causation is if those dots are in a straight line. So I cannot say the more you water a tree, the higher it grows, because that's not entirely true. If you look, these 2 dots here are the trees that were watered the most, but they are not the tallest height, right? This one is. So that is not a causation. So what I'm going to say is that it is positive, right? So the relationship appears to be moderately strong and positive, but is not causation. So something else you could say is that there is a correlation, a strong, so you could also say there is a strong positive correlation between amount of water and a tree's height. Okay, which we basically already answered part C as well. It says, is it possible to conclude that the more water you give a tree, the taller it grows? Why or why not? So again, there is a connection or a correlation, but not causation. There are other factors in play. And some of those factors could include soil and sunlight, how good those are for the tree, those kinds of things. Okay? All right. Well, a final example for these notes says, the following graph depicts the results of a class on a test measuring the number of problems missed with the number of hours studied. Okay, so if I'm looking at this, we just have two questions to answer. Analyzing the graph right away, I noticed that it is a negative correlation here. It is not causation because the dots are moderately spread apart. So I wouldn't say that it's a strong correlation, but it's also not weak as well. So if I'm going to say the data represents which type of correlation, I'm going to say negative. It's definitely going down. The more hours you study, the less questions you miss is basically what this is saying. However, there's a correlation between those two things. I shouldn't say the more you study, the less questions you miss, because that's not entirely true. But there is a correlation between the two. So then which statement can be concluded? Studying more hours causes fewer missed problems. That's not true because it's not a causal, okay? The person who missed the least amount of questions studied less than this person here did, so we can't say causation. There is a negative correlation between the number of hours studied and the number of questions missed. That seems to be true. Studying causes great test scores. Once again, not true. And then the last one says there is a causation but not a correlation between hours of studied and the number of questions missed. The first thing I want to say is there's no way to be causation and not a correlation at the same time. So that one is never the answer. So that means B is the correct answer. So there's a negative correlation between the number of hours studied and the questions missed. Correlation, yes. Causation, no. Okay? Again, causation, guys, that graph would be in a perfectly straight line if it were causation, and you couldn't find something like this point right here. This person missed the least amount of questions but did not study the most. This person did. So you cannot say that there's causation here. And that's it. That is the first half of organizing and analyzing data.